Okay, here we go with the final video. So this is part 2 of 10.5. We're going to take a look at combinations. Again, we talked about combinations in the last video, but it's the same idea as a permutation, but in a combination, there's no order to it. It's just a group, like how many groups of something can I have. So it's actually kind of funny when you think of your locker combination is actually not a combination. It's a permutation, right? Because the order would matter in the way that you put in the numbers. So anyway, when we do combinations, real similar notation, but instead of a P, we use a C. And again, I'm back to the N represents my total possible to choose from, and this represents how many of those am I going to choose within groups. So again, this one has nothing to do with order. It's about taking groups within the group. This one I would just do in calculator. The formula for this is a little more complicated than the one that we did up here. This one was a little simpler to lay out. This one's not quite as simple. So I would just do this in a calculator, so I'll give you one for practice. Let's just say we were going to do 10C4. So just like in the last video, my combinations are under the probability button, but I need to type in that number first. So I'm going to hit my 10, and then I'm going to hit probability. I'm going to scroll over to combinations and hit enter, and now I can type in the 4, and there we go. So you're generally going to find these numbers are quite a bit smaller than the permutations. Because the order doesn't matter, you don't have as many groups that you can choose here. So let me flip over to the next page. So this is actually the formula. This is what's going through your calculator when you do this. So you can see it's not quite as simple as the permutations, which is why it's best on those guys just to use our calculator for those. So let me flip to the page we were looking at in the last video. This is page 307. And I'm going to jump down to number 5. Sometimes they're nice and obvious, like on this one I don't have to figure out whether this is a permutation or a combination because it just flat out tells me that it's a combination. But remember, if you weren't sure by the wording of it, you might have to interpret whether or not there's an order. So if there's an order to it, that's what would make it a permutation. If it's just a group, then it's a combination. So for this one, so how many possible combinations of 3 colors can be chosen from the 7 colors of the rainbow? So remember that when you set this up, your total possible has to go first. You got to put the bigger number first. So there's 7 to choose from, and of those 7, we are only going to choose 3 of them. So, and then you would just put that into your calculator just like I just showed you, and that would be that. So let me flip over to a couple more examples with you. So there was a couple I had stolen from another workbook and put into here so you guys could see it. Just to give you some more examples to look at. So we got some ice cream going on here. So here's all our ice cream flavors. If you counted all those, you would see that there are 9 total flavors to choose from. So the flavors of the ice cream are served at an ice cream shop that are given here. I want a dish with 2 scoops, right, of different flavors. So I just want 2 different flavors in there. There's no order to that. It doesn't matter which one is first or second. This is just a bowl, and they're both going in the bowl, right? So there's no order to this. I simply want a group of 2. So of the 9 total flavors, I just want a group of 2 for my ice cream bowl, and that's it. So I know it's a combination because there's no order to it. And so that's our setup, and the rest would be calculator. So nice and simple. Pizza. So if there was 10 different toppings of pizza we had to choose from, how many different 5-topping pizzas could be formed out of those 10 toppings? Again, this is my total possible to choose from, and this is how many of those we're going to choose. And again, with pizza toppings, the order doesn't matter. It doesn't matter if you put on, pepperoni then sausage, or sausage then pepperoni. You got the same pizza. So that's why you can see this is a combination because there's no real order to it. So same thing with this one here. We have 20 students, to choose from, and of those 20, we're looking for a group of 4 students. So, and again, it's just a group of 4. There's no order to that. It's not like there's like a president, vice president, secretary, treasurer. There's no difference in ranking or value. It's just a group, and everyone has the same value within the group. So just taking those 4 students from the 20, and that's it. So let me see if I got a couple more I can give you real quick, and we'll call it quits. So here's the last piece. So this is where you would have to decide whether it's a combination or a permutation. So I have 8 members of a school band, and they're auditioning for 3 positions. So how many ways can they be chosen? So again, these are just 3 positions. They're all the same position. They're majorettes. And so there's no difference in value. There's no difference in order. So there's nothing that would suggest this is a permutation. It's just a group of 3, and they all 3 have the same value. So that would make this a combination. So let's see if we can compare that with this one though. So there's 35 students running this race. How many ways can they finish first, second, and third? So there's a definite order to this. There's a first place, a second place, and a third place. And apparently the rest don't matter. So anyway, so we know this is a permutation because there's an order to it. There's a difference in value, right, between first, second, and third place. So there was 35 total students, and we are only going to place 3 of them, right? And so that would be our setup. So that's it. That's it for chapter 10.